You're building a container home. You've saved for years. You found the perfect land. You're ready to start construction. But 35% of container homes fail structurally, not because of the container, because of the foundation. I've inspected dozens of failed container homes. I've seen families lose everything because of 5 critical mistakes during foundation design and installation. Today, I'm showing you exactly what those mistakes are, and more importantly, how to prevent them. I'm a structural engineer. I've certified container home foundations in 6 states. This is what I've learned. This is the biggest mistake. It costs between $1,500 and $3,000. Most builders skip it to save money. Huge error. Soil bearing capacity determines everything about your foundation. If you pour a foundation on soil that cannot support it, your structure will settle unevenly. Cracking occurs. Interior damage is catastrophic. Repair costs exceed $50,000. I inspected a container home in Oregon. The builder skipped soil testing completely. He assumed the soil was good because a neighbor's house was stable nearby. Wrong assumption. His soil had a high water table at 8 feet. Different soil composition, different bearing capacity. After 2 years, the structure settled 4 inches on one corner, 2 inches on the other corner. Differential settlement of 2 inches. Doors wouldn't close, windows cracked, interior walls fractured. The structure was literally twisting. The fix? Underpinning, driving new piers deeper. Cost? $68,000. The soil test would have revealed this problem before construction. Cost? $2,000. The math is simple. Spend $2,000 now or $70,000 later. Every single container home needs professional soil testing. Not optional, mandatory. Water is the enemy of foundations. Improper drainage destroys more container homes than any other factor. I visited a property in Georgia with standing water around the foundation. Water pooling, moisture constant. The builder said it'll dry out eventually. It didn't. Year 1, the foundation concrete began to crack. Year 2, water infiltrated the piers. Year 3, reinforcing steel corroded. Structural capacity degraded rapidly. By year 5, the foundation was failing, cracking visibly, settlement occurring. The solution? Install a French drain system around the foundation perimeter. Cost? $2,500. Should have been done during construction. Fixing it? Remove the contaminated concrete. Drill new piers. Install proper drainage. Waterproof the new foundation. Cost? $45,000. Drainage design must happen during the engineering phase, before construction begins, not after the foundation fails. Proper drainage includes French drains, sump pump systems, proper grading to slope away from the building, and gutter systems directing water 15 feet minimum from the foundation. In high water table areas like Florida and Louisiana, this is non-negotiable. The connection between your container and foundation is everything. This connection must be able to transfer loads safely. This connection must last 50 years. I inspected a container in Arizona where the builder used an untrained welder. The welds looked good, visually appeared solid, but they were poor quality inside. Micro cracks, porosity, improper penetration. The welds were fundamentally weak. Under wind load stress, those welds cracked. The connection began to fail. The container shifted. Structural integrity compromised. The solution? Complete re-welding using AWS D1.1 certified procedures. This means hiring a professional welder, using proper welding equipment, testing the welds for quality. Cost? $4,000 for remediation. But here's the thing. If the proper welds had been installed during initial construction, this cost would have been $1,000 included in the initial bid. Every single weld connecting the container to the foundation must comply with AWS D1.1 structural welding standards. No exceptions, no shortcuts. Professional welder, professional testing. This prevents catastrophic failure down the line. I worked on a project in Minnesota. Frost line depth is 4.5 feet. The builder designed piers going only 3.5 feet deep. He said, the soil is frozen anyway, so 3.5 should be fine. Dangerous mistake. Frost heave occurs when water in soil freezes and expands. This expansion can lift your foundation. If your piers don't extend below the frost line, the frost heave will move your structure up and down seasonally. Differential movement. Cracking. Year 1, minor cracks appear. Year 2, cracks deepen. Year 3, doors jam. Year 4, structural damage is visible. The foundation must extend below the frost line. In the Northeast, this means 4 to 6 feet deep. In the Midwest, 3 to 5 feet deep. In the Southwest, only 1 to 2 feet. This varies by region. Every region has different frost line depths. Your engineer must verify frost line depth for your location and design accordingly. Ignoring frost line requirements guarantees problems. Repairs require underpinning. Cost $30,000 to $50,000. You pour your foundation. You place the container. Everything looks perfect. Then you wait. Settlement happens. Normal settlement. Soil compacts under load. Concrete cures and shrinks slightly. The structure settles 1 to 3 inches in the first year. This is normal. But if settlement is uneven, if one corner settles 3 inches and another corner settles 1 inch, differential settlement is occurring. This is the silent killer. Differential settlement causes tilting. Tilting causes cracking. Cracking allows water intrusion. Water causes structural problems. Months later, you notice doors jamming, windows cracking, and interior walls fracturing. But you don't know why. You don't see the differential settlement happening. The solution? Monitor settlement for the entire first year. Measure all 4 corners immediately after the foundation cures. Then measure monthly. Compare measurements. If differential settlement exceeds 1/4 inch, contact your engineer immediately. I visited a container home in Tennessee where the owners never monitored settlement. By the time they noticed problems, differential settlement had reached 3/4 of an inch. Severe cracking throughout the interior. Repair cost $35,000. The monitoring would have taken 30 minutes every month. Cost $0. You just need a laser level and a notebook. Catching differential settlement early means the engineer can make adjustments before structural damage occurs. Catching it late means catastrophic repair bills. I want to show you what happens when these mistakes combine. I inspected a container home in rural Oregon. The builder made all 5 mistakes. 1. No soil testing. He assumed the soil was good. 2. No drainage design. Water pooled around the foundation. 3. Poor weld quality. The connection was weak. 4. Piers only 3 feet deep in a region with 4-foot frost line. 5. No settlement monitoring. Nobody checked what was happening. Year 1, everything seemed fine. Year 2, cracks appeared. The owner thought, just cosmetic cracking, normal. Year 3, doors started jamming. Windows cracked. Interior walls showed significant cracking. Year 4, the owner finally called me. By this time, the damage was severe. Soil testing revealed the water table was higher than normal. The shallow piers were experiencing frost heave. Differential settlement exceeded 1 inch. The welds were cracked. Structural capacity was compromised. The repair cost? $147,000. The owner lost the investment completely. The structure required extensive underpinning, drainage system installation, weld replacement, and interior reconstruction. The owner thought he was saving money by skipping engineering. He ended up losing everything. The solution is professional engineering from day one. Before you dig a single hole, hire a structural engineer. That engineer will require soil testing. The soil test informs the foundation design. The engineer designs the drainage system. The engineer specifies the weld requirements and connection details. The engineer creates a settlement monitoring plan. During construction, the engineer supervises installation. After construction, you monitor settlement for year 1. This is professional engineering. This is the standard. This is how container homes are built correctly. Yes, it costs money, Professional engineering costs between $6,000 and $15,000 for a container home foundation. But compared to repair bills exceeding $100,000, it's the best investment you'll ever make. If you're planning a container home, start here. Step 1. Hire a licensed structural engineer, PE, licensed in your state. Step 2. Your engineer will specify soil testing requirements. Step 3. Conduct professional soil testing before foundation design. Step 4. Your engineer designs the foundation based on soil results. Step 5. Follow the design exactly during installation. Step 6. Monitor settlement for year 1. This is the correct process. This is the process used by professional builders. This is the process that prevents structural failure. The 5 mistakes I showed you today are completely preventable. They occur because builders try to save money on engineering. Don't be that builder. Your investment is too important. Your family's safety is too important. Build it right the first time. Subscribe for more structural engineering content. We break down the technical details you need to know before building your container home.